Hello students. In the previous video we have studied about system of units, and we defined it as a complete set of units which is used to measure all kinds of fundamental and derived quantities. And the commonly used system of units we have studied are as follows. These were CGS, FPS, MKS and SI system. For in CGS system, the units are centimeter, grams and second for mass, length and time. In FPS system, for mass it is pound, for length it is foot, and for time it is again seconds. In MKS system, unit for length is meter, for mass it is kilogram, and for time it is seconds. In SI system, now SI system is the international system of units, and it contains 7 basic SI quantities as well as 2 supplementary one. Okay, so now in this video we are going to study about SI system elaborately. So SI system is the international system of units. We can write it as the international system of units. This system contains 7 basic and 2 supplementary quantities, right? 7 basic and 2 supplementary quantities. These 7 basic quantities can be written as, we are taking these quantities. First one is length, second is mass, third is time, fourth is temperature, after that electric current, next one is, sixth is luminous intensity, and the last one or the seventh one is quantity of matter, or we also called it as amount of substance, right? The seventh basic quantity this unit is, or the quantity is quantity of matter, or we called it as amount of substance also. Now these fundamental or the basic quantities has basic units. For length, its basic unit in SI system is meters, for mass it is kilogram, for time it is second, temperature it is Kelvin, we measure temperature in kelvins in SI system, for electric current it is ampere, for luminous intensity it is candela, and for quantity of matter it is mole. Quantity of matter is denoted by the unit called mole. Now come to the supplementary quantities. So there are 2 supplementary quantities in SI system. These quantities are, first one is plane angle, and second one is solid angle. First supplementary quantity is plane angle and the second supplementary quantity is solid angle. Now the basic units for these supplementary quantities are, for plane angle it is radian and is denoted by the word RAD, and for solid angle it is steradian and it is denoted by SR. Okay, so for plane angle the unit is radian and it is denoted by RAD, and for solid angle it is steradian and is denoted by SR. These are the quantities that we used in a SI system to explain any kind of fundamental or derived quantity present. Okay, so we had 4 systems: CGS, FPS, MKS and SI system, and among these four systems, the most used or the commonly used system is the SI system. So the question is, why we are using SI system the most, or what are the advantages, uh, of SI system over other system of units. Okay, so now we are going to discuss the advantages of SI system as compared to the other system of units. So the advantages of SI system are as follows. First one is that this is a coherent system of units. First we write all the advantages, then we explain them one by one. So the first advantage of SI system over other system is that SI is a coherent system of units. Second, it is a rational system of units. Okay, so SI system is a rational system of units. Third is, it is a metric system. SI is a metric system. Next, SI is an absolute system of units. SI is an absolute system of units. And fifth and the last one is, it is an internationally accepted system. That's why we call it as the international system of units. So the last one is, SI is an internationally acceptable system of units. Okay, so this is the last one. Now we explain all these points one by one. So the very first point is, SI system is a coherent system of units. For this we have to know what is the coherent system. So whenever there is a system of units based on certain set of fundamental units for which all derived units can be obtained either by simple multiplication or division without introducing any numerical factor, then such system is called SI system. That means if we have a system of unit based on certain set of fundamental units, so we have a set of fundamental units from which we can derive all other units by just multiplication or division, we don't have to introduce any new numerical factor in that, then such type of system is called coherent system of units. And in case of SI system, that is true, means for SI system we have a certain set of fundamental units that we have studied, 7 basic and 2 supplementary, and we can derive all other units from these fundamental units either by multiplication or just by division. We don't have to introduce any numerical factor there for any kind of derived unit. That's why SI system is a coherent system of units. Okay, this is the first point. Now SI system is a rational system of unit. Rational system of unit actually means it uses only one unit for a given physical quantity. Means a particular physical quantity has a given as only one unit that is given, right? There is not multiple unit for a single quantity. For example, if we take MKS system, now MKS system may we use mechanical energy. If we take mechanical energy, then we have to measure it in joules, heat energy in calories, and electrical energy in watt hours, right? For example, if we take MKS system, there the mechanical energy is measured in joules, heat energy is measured in calories, and electrical energy in watt hours. While in case of SI system, we take unit of energy for all forms of energy as joule. So it is a rational system of units. That means it uses only one unit for a given physical quantity. Next advantage of SI system is that it is a metric system. That means the multiples and submultiples of SI units can be expressed as the powers of 10. SI system is a metric system. That means we can express the units in the multiples and sub multiples of SI units as the powers of 10. Okay, so जितने भी हमारे पास मल्टीपल्स और सब मल्टीपल्स हैं SI यूनिट्स के, उन सब को हम एज द पावर ऑफ 10 एक्सप्रेस कर सकते हैं. That's why it is called a metric. It is a metric system, and that is advantageous for us. Next point is that SI system is an absolute system of units. That means it doesn't use gravitational units. The use of small g is not required here. Absolute system of unit means the use of small g or the gravitation is not necessary. It doesn't use gravitational units. That's why it is an absolute system of unit. Okay, and the last one is very common, that SI system is an internationally acceptable system. That's why we use it the most. सबसे ज़्यादा इसको यूज़ करने का रीज़न ये है बिकॉज इट इज़ एन इंटरनेशनली एक्सेप्टेबल system of units. So these are all the advantages of SI system. Now we have certain units or practical units that we use for different calculations. So we have a list of some commonly used practical units that I am going to show you here. So here we are dividing these practical units in 7 category. Category number 1 is the practical units for measuring small distances. Okay, first of all we are going to see what are the practical units that we use while measuring small distances. So in this case we have 4 units. First is Fermi, then angstrom, after that nanometer and micron. So these are the 4 main units that we use generally to measure small distances. Let's see what are their values in terms of SI system or how they are related to their SI units. So 1 Fermi, we write it as FM. Sometimes we also called it as femtometer. Okay, Fermi is sometimes also called as femtometer. Now 1 Fermi is equal to 10 to the power minus 15 meter. This is how it is connected with the SI system. Similarly 1 angstrom is equal to 10 to the power minus 10 meters. 1 nanometer is equal to 10 to the power minus 9 meters, and 1 micron, micron is micron or micrometer, is equal to 10 to the power minus 6 meters, right? It is also known as micrometer. Mu m, the letter, this letter is called mu. Okay, this is mu, mu. Micrometer is equal to 10 to the power minus 6 meter. The second category is to find the distances or measuring the large distances. Okay, this was for small distances. Now the second category is for large distances. For large distances we have 3 main units. First is light year, second is astronomical unit, and the third one is parsec. Okay, so these are the units which we use for large distances, and these are connected to SI system as 1 light year, we write it as LY. 1 light year is actually equal to 9.467 into 10 to the power 15 meter. Now this is plus 15 because this is for large distances. Okay, here we have negative signs because these are for smaller distances. So 1 light year is equal to 9.467 into 10 to the power 15 meter. 1 astronomical unit, it is represented by AU. 1 astronomical unit is equal to 1.496 into 10 to the power 11 meter, and 1 parsec, or sometimes we called it as parallactic second. 1 parsec is equal to, it is represented as 1 parsec is equal to 3.08 into 10 to the power 16 meters. Okay, 3.08 into 10 to the power 16 meters, or 3.26 light years. In terms of light years, it is equal to 3.26 light years. Third category that we are going to study is about to measure areas. So areas can be measured in the following 3 units. First is barn, second is acre, and the third one is hectare. Here 1 barn is equal to 10 to the power minus 28 meters square. 1 acre is equal to 4047 meter square, and 1 hectare is equal to 10 to the power 4 meter square. Okay, so 1 hectare is equal to 10 to the power 4 meter square. The next category is for large masses, when we have to measure large masses. So there are following categories. First is 1 ton, or we also called it as 1 metric ton, and it will be equal to 1000 kilogram. Okay, next one is 1 quintal, and it will be equal to 100 kilograms. Next is 1 pound, and it is equal to 0.4536 kg, means almost half kg. These are the practical units that we use for measuring large masses. The next category is to measure very small masses. So the next category is for small, or I should say very small masses, and such masses are measured in the units called atomic mass unit. Okay, so this is the unit that we use for measuring very small masses, and 1 atomic mass unit is actually equal to 1.66 into 10 to the power minus 27 kg. Okay, so this is the value. 1 atomic mass unit is equal to 1.66 into 10 to the power minus 27 kg. Next category is to measure time. If we want to measure time, then the main units that we use are solar day. Okay, now solar day is the time taken by the earth to complete one rotation, that is our actual day. Next is the solar year. So 1 solar year is actually equal to 365.25 average solar days, means it is the time taken by the earth to complete one revolution around the sun. This is the time taken by the earth to complete one rotation about its own axis with respect to the sun, while solar year is the time taken by the earth to complete one revolution around the sun in its orbit. इसमें अर्थ अपने एक्सिस पर रोटेट करता है, while सोलर ईयर में अर्थ around the sun one revolution complete करता है, and 1 solar year is actually equal to, now this 1 solar year is equal to 365.25 average of solar days, right? 365.25. After that, the next units in which we can measure time is lunar month. The third one is the lunar month. Now it is the time taken by the moon to complete one revolution around the earth in its orbit. So lunar month is the time taken by moon to complete one revolution around the earth in its orbit, right? And the last one is the leap year. This year is the year which is divisible by 4 and in which the month of February has 29 days is called a leap year. Okay, so leap year is the another unit or another practical unit that we use for measuring time. The next and the last category of measurement is the practical units used for measuring pressure. So pressure can be measured in terms of bar, okay, and 1 bar is equal to 1 atmospheric pressure. 1 atmospheric pressure, and it is equal to 10 to the power 5 Newton per meter square or 10 to the power 5 Pascal. Also 1 millibar is equal to 10 to the power 2 Pascal, because milli means 10 to the power minus 3. And the next thing is 1 torr. We can also measure pressure in terms of torr. 1 torr is equal to 1 mm of mercury column, right? So 1 atmospheric pressure, or I can write it as 1 atm, is equal to 1 bar is equal to 760 mm of Hg or 760 torr. Okay, so this is the relation to measure pressure. These are the practical units that we use for measuring pressure. So this was about the SI system, or the practical units that we use on regular basis for measuring different physical quantities. That's all for this video. In our next video we will study about the order of magnitude and how can we measure length by using direct and indirect methods. Okay, so for that stay tuned and keep studying. Thank you.